We are super excited to have this speed talk about machine learning. It's going to be a novel introduction. We are just scratching on the surface on a very big topic. This is a brainchild presentation of two presentations and a roadshow material that we have that is over 2.5 hours. So bear with us. We are condensing it down to 20 minutes, and we are going to speak intense a lot and save the questions to later, because we are going to speak until they drag us off the scene or cut the mics. So we will be available off scene afterwards for questions. So who are we? Simon.
Hi everyone, my name is Simon Ogden. I'm a sales engineer based out of Splunk, Sweden.
Yeah, and my name is Magnus Johansson. I work in IKEA. I have the title of Solution Architect, which is a good title, meaning that you can do basically everything you want to within Splunk. But remember, Splunk is just my hobby. It's a passion of mine. My real work is actually a farmer. And I'm not kidding. I have my own sheep, chickens, and forest and do all of that. That is my real work. So you have seen this page before. I'm obliged to show it to you this time as well. But what we want to do now is just to give a small common base on what Splunk is and why machine learning. Simon?
Yes, so Splunk in 30 seconds. Why do customers invest in Splunk? And why do they need to apply some machine learning on top? So put it really simple. Splunk makes it possible to refine your data to measurable business value, to get knowledge, turn your data into knowledge. And I know that our slogan, official slogan, is turn the data into action, turn your data into doing, but it all starts with turning the data into knowledge, because that is what we compete with. And sometimes we need to add some machine learning on top to get that extra knowledge. And why the need for machine learning? Well, the human brain is super fast, super intelligent, but we cannot cope up with the volume. But it's not just the volume, it's actually the thing. We have something called gut feeling, has been really helpful, but maybe not always. So I'm going to give you an example, and that has to do with the difference between probability and likelihood. So you all guys are now leaving on vacation to a nice island, and you know by fact that 1 out of 10,000 comes back with dengue fever. Not that much, but you go there anyway. And when you get back, you think, maybe I should test myself. So you go to the hospital and you ask the nurse, what's the accuracy of the test? And she says, you can be sure, it's like 99.9%. The test result comes back and it shows that you are actually carrying the virus. So the question would then be, what's the likelihood that you are carrying the virus? From a mathematical point of view, this is a really simple question. It's a Bayes' theorem. And it's a really old formula. The answer is it's 10%. And for so many people, this is really hard to grasp. Why is it 10%? From a mathematical point of view, it's really simple. The good thing here is that the potential of applying machine learning on your data is not just limited to prediction of likelihood of viruses. Since the fabric of nature itself can be described in a mathematical way, as long as you have the data, the possibility is endless, right? And this is nothing new. The old Greeks, they clued that out for like thousands of years ago.
Even for Greeks.
Even for them.
Yep.
But it's not a silver bullet in any way. One of the classic pitfalls is what we call torturing the data until it just confesses. Because you would like to have the answer, and when you find the answer, okay, I found the right algorithm. So this is the Bible code. It's a book about the Bible. And this has nothing to do with religion, but it actually points out that if you're applying an algorithm to the text in the Bible, you can find patterns, how they predicted the election of Obama, for example. And then there was some data science in New York. They came out with exact same values, where they just crunched the text in Moby Dick. Same result, different data sets. Yeah. If it's truth or not, that's for you to decide, right?
So you need to be objective in this area.
So over to you. Did you find any pitfalls? What was the first one?
A lot, a lot. And the first one that we started exploring with the proof of concept to try to apply machine learning techniques within Splunk and look at the different aspects on how you can use it. One of the first challenges that we came across is it all starts with data. If you don't have any data, well, you can't apply machine learning. And if you think you have the data, maybe that is the wrong data. So we thought we had the data and realized that we need to actually reinvent how we are collecting the data for databases, for example. Because it needs to have a certain frequency. It needs to be, you can't work with aggregated data, and you need to, and when you think about it, measuring, if you measure something, if you want to measure your pulse, does it matter if you have check it on the right arm or the left arm? Is it the right pulse? So you get a certain frequency with the pulse. It's very regular. So when you have a big data set with a lot of variables, do you want to crunch machine learning on that? Because it gets exponential, a lot of compute of that. So there is a way that you can actually compare the different metrics, the different variables, to each other and reduce the data set. And this is important because you want to reduce the data set. Either you do that in RStudio, or there is an algorithm within Machine Learning Toolkit that can help you also reduce the number of data set. And when you start working with the data, we go into the area of applying different algorithms. And since we're just scratching on the surface here, there is two major classification of algorithms that you need to be aware of. The first one is classification. Look at something and tell me what it is. So it doesn't give you a number or something like that. It gives you, I think it is a cat or a dog or whatever. And if you start thinking about it, you can actually show this with a small video where you can use Google's machine learning algorithms, upload a lot of pictures of known data, what you know of, train and say, give me a model that is actually looking for faces, and apply that to a robot and look at the big and actually identify all the faces. And out of those faces, apply the machine learning technique and say, where's Veldo? So this is classification. So it is a little bit about going into supervised and unsupervised machine learning algorithm. Supervised is when you have known data and are looking at the unknown and tell me what it is. Unsupervised is more, you don't know what you have, but you know what output is. The other major algorithm that is used to 80% of the user cases within machine learning area is linear regression. It's an algorithm that gives you a number. And to give you an example of that, if I want to sell my house, what is the reasonable price that I should put my house on? Well, to give you a typical Splunk answer is, it depends. It depends on how many rooms you have, how many square meters, what is the distance to city, and if you have fiber or not connected to the house. And out of that, it gives you a prediction. You should sell your house for this price. Linear regression. It's depending on different features, the number of rooms, the square meters, and so on. And when you get the prediction and you sell the house, you can then compare what was the difference. How far off was I with my guessing? And if you measure the distance between the labeled data, what you know on and compare it to your prediction, you can see how far off you were. So when you're working with the data set, you divide it into, here, trying this model on this part of the data and test it here. You can't train and test on the same data. It was like going to school and have a test and you know all the answers. It's like cheating. That would be giving you an overfitted model. So we are talking about a lot about machine learning here. So I just want to, a personal opinion, what is then artificial intelligence? Artificial intelligence is something for me that is simulating a mental thought. When people are talking about AI in different tools, they're actually talking about machine learning techniques that is applied in different variations. It will help you, it will support you into a rule-based decision tree, for example. But for me, there is no AI, because an AI or machine learning can look at this picture and say, hey, there is someone throwing a frisbee. But AI is very narrow. It doesn't say, hey, does it make sense if it throws the frisbee 30 kilometers or if the person is only 2 months old? The AI doesn't know that. So we are waiting for this super intelligence artificial. Then we can start talking about. And usually my personal belief is AI is overestimated in the short term. In the long term, it's underestimated. So can you just tell me a little bit about different machine learning techniques that we have in Splunk?
Yeah, I do that. So this is going to be like 90 seconds crush of the machine learning toolkit. So the machine learning toolkit is an app. And the value of that app is it actually puts your SPL on steroids, right? It's an extension of the search language into, I think it's like 300 open source algorithms. So it's not the algorithms per se that makes it powerful. It's a combination of the algorithms on top of your existing data. And it's built in such a way that it actually helps you combine them with the pre-built use cases. So one example would in this case be how we actually enter a search, a simple search. I just use a transaction command, point that to a field. The command then actually going to create another field with a numeric value. In this case, it's duration. I use some kind of mathematical calculation. In this case, it's not machine learning, but it's a standard deviation. I have some thresholds, right? But remember what we talked about in the beginning. It has actually no value if it can't turn it into knowledge. And one way to turn an answer into knowledge, into make it more, put it in the right context, right? So I would say it doesn't stop here. This is of no value. But the good thing is that it's integrated with SPL. So yes, open it as a search to put it in another view, and then you start to munch and contextualize your finding. So in this case, I just add some enrichment command with the IP location to get some other fields. I filter out anomalies to see, how can I put the duration numbers that were the outliers into a bigger context. So that's how you can think about using the machine learning tool in a very simple way. But that's just PowerPoints. Could you give us more, in real life example?
Yeah, because remember, machine learning is not the silver bullet to all your problems. We can look at where you can apply machine learning techniques, and that is what we did the proof of concept a couple of years ago. And we took one scenario that we would like to know, can we predict whenever a database will fail? And if you look at the aspect, if the table space is running out of space, guess what? The database will not be able to ingest more data and it will crash. So, and we have a lot of databases and there's a lot of tedious work to mitigate them and solve that. And yes, you can solve this issue in many different ways, but the only way to learn is by doing it. And that is my recommendation, start playing around with it. So we started off with machine learning technique toolkit, and we took data for one server, about 3.5 months of data, and we look at all the different metrics that you can get from the operating system and together within the Oracle area. And the search that you might be able to see here on the screen is that you basically bucket all the data together and look at for every 15-minute time span, what was the value for that? And off we went. And the result was that, yes, if we look at the blue line here, and it's overlaying with the yellow line, basically meaning that, yes, the file consumption went down, or file usage space, free space went down, and we could have predicted it if we didn't know that metric. That was the key takeaway. Yes, you can do that. And as you can see, there is a value here called R square, meaning basically how far off were we with our prediction. And the only thing that you need to remember is that that value is between 0 and 1, and the closer you are to number 1, the better. If it's like 0.5, you're way off. It also gives you a number of features or values that, hey, these are better suggested looking into future. If you want to reinvent this model, apply these metrics. They are better suited for the model. So that was for one server, and guess what? We have a lot of Oracle servers. So we went into the area of ITCI instead. And ITCI is a good way to group all the KPIs together that you know about into a context of a business. And there is 3 major KPIs that is always important if you're looking at the service. This is the response time, number of errors, and the number of transactions. If you don't know any KPIs that you want to look at, start with that. And within ITCI, it gives you, this is a slide from the general ITCI presentation, meaning that you have a lot of problem normally in the organization, in the IT landscape. You get an alert and start fixing that. And if you're really good at it, you can start automate the resolution of the problem. Again, you can solve this problem a lot of different ways. But what is cool is that you can actually start looking at what is happening before and get an early indication on what is about to happen. Because everyone knows that the longer that you have an incident open, the more it costs. And can you actually start working on the problem before it gets an incident, you're actually putting back money to the organization. So here is a screenshot of our proof of concept implementation. We have grouped some services together, and in the middle you have the Oracle service, which is an important part of a lot of the business applications that we have. You also can see that we have selected KPIs for that Oracle area, and what is the service behind it. And basically, we selected all the servers. And where is machine learning in all this? Well, it's here, because you have all the metrics. You can see how it's varying over time. Those metrics, KPIs, are being aggregated up to a health score, meaning how good or bad we are running our service. Machine learning is the predicting part, where it says, in the near future, you will have a problem, or it will be a better solution. And the good part is that it can give you a head start, predicting. But remember, predicting is not the same thing as root cause analyze. So that's why you have the deep dive. You need to go down to the metrics and see what is happening. And what we did in this proof of concept as well was ingest all the ticketing systems that we have. So we have a ticket here, and we can see what happened just before that ticket was created. And then you can start learning about that symptoms. Maybe we can set up a multi-KPI alert or something else. So that was ITCI. But how about if you want to apply machine learning per entity? Because you act per database. You don't act on any service like random servers. So what we did was inventing some SPL functions that is looking at one feature in one variable and gives us a table of recommendation. Here, based on 7 days of data, the next guess of 24 hours is that it's going up or down. Here is our recommendation of, you will have a problem, maybe you should extend the file system already now. But you also can see that there is some red here, meaning they are completely empty. You could not have predicted that because it happens directly. So what our learning was, is that you need to combine a machine learning technique with a fail-safe. So if you have something that is predicting, guessing, you need to have the fail-safe as well. Regardless whether it's the fail-safe or the prediction, it triggered the same automation. Here we had a workflow in Ansible Tower, checking whether there is disk available and then extend that to the Oracle database. solved. The good part is that this endpoint can be called upon manually or from another alerting tool. And what is important is that you close the loop. Having data in Splunk, applying machine learning and technique, guessing, if you don't act on that, you need to do something about it. And as you can see, the data that we bring in is used for many different purposes, not only for prediction on preventing outages, but the data is just data. How you look at it, I don't really care. So closing the loop is not, that's really important. And the SPL was actually reusable in such a way that you can apply that on any type of metrics if you want to apply machine learning technique in one variable. So it was reusable for file systems as well. All right, so that was a couple of different examples on how we applied it. And one key takeaway of this is that the learning was correlation is not the same thing as causation. And what do I mean with that? Well, if you look at all the data you have in Splunk, and I will apply machine learning to prevent all the future problems that we have, it doesn't really matter. If it just happens to find something that is correlating with your prediction, does it really have the same? Are you looking at the symptom or the root cause? And you need to be aware of that, but because you can have many different curious correlations if you over-massaging the data, torturing the data. You can say that there is actually a correlation between the number of IKEA stores you have in a country and the number of Nobel Prizes that you have in the same country. Is that true? I'll leave it up to you. So, Simon, I would like to summarize here what is our best key takeaway is you need to have domain knowledge.
Indeed.
You need to know what the data is coming from. And you need to have some Splunk expertise, right?
And if you find one guy who have all these expertise, hire him.
Yeah.
So far, we haven't found him.
And you need to have knowledge about data science. And remember, I'm not the expert on machine learning here. I'm expert on ranting. So don't take anything I say for the absolute truth, right? I hope this gives you some ideas and a novel introduction and a quick guide. Feel free to come hunt us down afterwards if you want to see more on what we did, or if you have any, if it sparks idea or raised any questions. But my best key takeaway is don't say to the organization, where can I apply machine learning? No. Give me the problem, and I can maybe say machine learning is one of the tools to solve your problem. And there is no AI yet. Thank you very much.
Thank you.